All right, I think we're ready to start. So welcome back for the third module for the Python workshop. Uh, and I guess we can just jump right in. All right, so the next thing we're going to learn about is functions. So a lot of times you might create a useful program. Let's say your program determines whether or not a certain number is a prime number. And let's say you uh, want to create a program that uses that bit of code uh, to find the prime number, and you want to use that code again. Instead of copy pasting the code, you can condense it into one line, one term, I guess you could say, of a call. You can call just like one word, and it will run the lines of code that you've made. So the thing you would call in this case is called a function. And the declaration of a function is starts with a def, as like define. The name of the function, we're just going to do pseudo, I don't even know. Yeah, pseudo print. Yeah, pseudo print. This function is just going to print x and x. Okay, so this is the basic body of the function. Starts with def, the name of the function, and then in the parentheses you can put whatever you want here. You can put as many variables you want. No, not x. Put y, z, a, b. You can put as many variables as you want here. And essentially what these are is when someone calls your function later on, whenever they put in parameters, like 3, 4, 5, 6, 7, yeah, 5. You can use the values that they input in your code. That makes sense. So I'm just going to use one parameter for this example. Pseudo print, all it's going to do is just going to run this one line, print x. So now whenever I call pseudo print, it's going to be the same thing as calling print. You can think of functions as taking the code written inside the function and copy pasting it wherever the call is. Of course, there's also the parameter. So also you have to put the parameter in properly and its uses. But that's pretty much how a way to think about it. Pseudo print is just print, technicality. So if we do pseudo print 3, if we run it in the shell, it should just print 3 when we call pseudo print. We print hello world. It should just pseudo print hello world should just be the same thing as print hello world, and it should print hello world. So yeah, maybe you want to do a function that takes the sum of two numbers, x and y. You want to print the sum of x and y. You could alternatively make sort in a variable x plus y, or you could just do print x plus y here, but same thing. Just to show that you can put multiple lines. If I try to call sum of x and y, it should print, oh, x and y are defined. Let's say you want to take the sum of 5 and 6. So the sum of 5 and 6 is 11. You should see a print of 11 because we passed in a 5 as x, passed in 6 as y. So s becomes the 5, which is x, plus 6. So s becomes 11, and then we print that 11. So it's essentially the same thing as just copy pasting this code here and replacing x and y with whatever our parameters were. That's useful. So now I can just call some multiple, maybe my code requires the summation of multiple numbers later on, instead of having to type, okay, I mean, I guess this is can also be done in one line, but you get the idea. If you have multiple lines, you can call it simply in one call using a user-defined function. One other useful thing about a function is that they can return values. So we saw that whenever you had, for example, if you have s equals len of some random string, bird, let's say, this should len of bird is going to return the length of bird. So it's going to return an integer 4 because then there are 4 characters in bird. So the way this works is that len, it takes out a value for you to assign, right? The way, if you want to do let's see the different value, a is equal to sum x 5 and 6, we can do this if we get sum to return a value. How you do that is quite simply, you just type return s instead of print s. Now, if nothing is getting printed, by the way. Before, we had a print statement inside of sum. So if we called a sum, it would have printed something in the console. But nothing is going to get printed in the console because there's no print statement. And no print statement is getting run. No print statement is getting executed inside of sum, nor is it getting executed out here. But we can call a, we can print a. And a now has a value of whatever sum is. Oh, and put a. So print a should be sum of 5 and 6, so a should be 11. If we print a, it should be 11. So that's how you can retrieve values from functions. And generally, you want functions to return stuff instead of just printing it. Though printing has its uses sometimes. Yeah, so that's how you return from a function. Yeah, you can pretty much just write an algorithm and call it on call. Moving on, unless anybody has any questions, functions, comment this. So the next thing we're going to cover is libraries. So before I talked briefly when we were talking about documentation, is that you can use functions that come with Python. Some functions require importing a library. A library is just a group of functions. But so similarly, how we define a function here, if you want to, some people make they create functions and then they make them available for other users to use in a library. And in order to define their functions in your code, you have to import their library. So in this example, we're going to use something called the random library. From random, oh, sorry. Sorry. Okay, so this is a basic library import statement. Quite simply, breaking it up, this is the name of the library you want to import. And then normally after this import, you would type the function you want to import. We're going to use the randint function. So from random import randint would define randint for you, and then you'd be able to use it. But I put an asterisk here just for 2 reasons. One, it's just shorter than typing randint, but 2, because in case sometimes you'd want to use all of the functions from random, putting a star just means to import everything from random. You might not always want to do that for efficiency reasons. You don't want to define every single function inside of a library because it takes longer than just to import that one function you want, but it's just shorter to type, and I won't really see the efficiency here. So we're just going to do star. From random import star just imports everything from random. So we're going to use something called randint, and we're also going to use a loop. So randint, what it does is it generates a random number between A and B. Let's say we want to generate a random number between 0 and 5. And we print, say R equals randint print R. This should, every time we run this, we should get a random number between 0 and 5. So, oh, luckily we got 0. If we run it again, huh? That's odd. Wait a minute. Why is it? Whoops. Yeah, okay, 1. How do we get 0 3 times in a row? Yeah. Okay, now it's, yeah, okay. I don't know, it's printing, yeah, it's printing other numbers other than 0 now. Yeah, every time you run it, it takes a random number and prints it. And this, now we're using it, if we were to use randint, oh, sorry. If we were to use randint without importing, so to comment this out, we get an error because it's not defined. And it's also not, it's not a predefined function in Python, similarly to like len or int, like the int wrapper that we used for strings to convert strings to ints. Usually if they're not blue, I mean, I'm not sure if your code highlights the functions that are predefined. Usually if they're blue, you don't have to import anything for them. Dot append is predefined, but that's a different topic. Yeah, you see, random isn't defined because we didn't import it. So you have to import it to use it. So yeah, let's try this in a for loop just to make it in range. Let's print 10. Let's just print 10 random numbers. Instead of 0 to 5, I'll do 10. Okay, this prints 10 random numbers between 0 and 10. So yeah, this is a useful function because it's pseudo-random number generation. Maybe you want to, maybe if you're like generating a random level, for example, you want maybe like platforms to appear randomly. You don't want something to generate. You probably don't know how to make a function to do pseudo-random number generation. So it's useful to use external libraries. Okay. I completely forgot. We are actually done for the lesson part of the Python workshop, but I completely forgot that to take up the practice 2 problem. So we're gonna do that. So yeah, did anybody, what if I just walk it through with you? Okay, so practice 2. Oops. Try seeing if you can make max occurrence program. So the program takes space separated integers as a variable directly in the code. We can just take a list actually. Takes a list. Okay, so let's just say the program takes a list and the program outputs which integer has the most occurrences. So essentially, let's say, so here we have 3 repeating ones. I think 1, 2, 3, 4, 4 repeating 2s. I think the 4 repeating 2s is the max amount of occurrences, so you output 2. It's the most frequent integer in this list. So 3 is the most frequent integer in this list. There are a lot of 3s, so you print out 3, and so on. So that's quite simply what it wants. So let's try to do that. So the first things first, we need to take a list predefined. I'm just going to copy paste the sample input in equals this. So we need to do, so obviously we need to we need to look through every individual element. And one way to do that is use one of the most obvious ways is to use the for each loop. So for num in int. Now for every number input, what I'm going to do is I'm going to store the unique numbers in input. And then I'm just going to store them in a separate list. So unique equals do this. Actually, I have to define this outside because I don't want to, because every time this loop runs, it's going to empty it out if I leave this line here. It's empty. So for every num in input, if, okay, so here's a useful function, unique list dot contains. It's a useful function and it just checks if this list contains whatever you put in this parentheses. So what I'm gonna do is in order to insert unique stuff into dot contains, or in order to insert unique numbers into unique, we're gonna check if each number that we iterate through is already in unique. And if it isn't, just add it. So unique, okay, so this returns a Boolean. So we're gonna put an if statement here. And we're gonna use our condition unique.contains num. So, and we're gonna invert this Boolean because we don't want to add it if it contains it, but we do want to add it if it doesn't. So we only want to add it when this is false, and this will only if we do false and then exclamation mark, oh sorry, not exclamation mark, not. If unique doesn't contain the number, then we add it. Dot contains the Boolean, so just to repeat. So this should work. So unique to append dot append num. So now these two lines just at the end of the loop, after look, it'll add all the unique numbers into unique. So if we try to print unique, you can see that we won't have any duplicate numbers. Huh. Was it dot contains? Let me look up the documentation. Documentation contains. Actually, list. Oh, let's see. Data structures. List. Okay. Yep. Count sort. Okay. I was thinking of a different programming language for dot contains. Python's list doesn't have dot contains. One thing I do see is that it has a list dot count. So one way we can think about it is if unique dot count num is equal to 0. Sorry, equals to 0. So we add it if it doesn't have the number already. So yeah, that's one way. Instead of that's a workaround for checking if it contains it. Instead of this pretty much just means if it doesn't contain. It's a translation. You could say this should work. Now we have a list of all the numbers in this list, all the unique numbers in this list. See no duplicates. So next thing we're going to do is we're going to do another for loop. And we're going to actually iterate this time for u in unique. And this is a bit of a tricky concept, but we're going to actually nest for loops here. We're gonna put a for loop inside of a for loop. It may seem weird, but what my approach is that, okay, in this case, unique has 2, 4, 7, 9, 8, 6, 5, 1, 3. So we're gonna iterate through each number. And then let's say we're starting with 2. I'm going to take a count of how many 2s there are. Right? And then I'm going to store that in a dictionary. So the dictionary will come later. I'll just define it here. Counts equals some empty dictionary. And we also need to define, okay, I'll name a count variable later. Actually, I'll do it here. Count equals 0. What we're going to do is we're going to, let's say we start with 2. We're going to go through every, so we're going to start with 2, and we're going to go through every index and input. And if it's a 2, we just increase its count by 1. And then at the end of the list, we're going to add that counts number and the key 2 to the counts dictionary. And then actually, there's a better way to do this instead of counts. We're gonna, instead of a dictionary, I'm gonna use just most frequent, let's say. Sorry. Change of plans. Frequent equals string. Okay, so okay. So f times equals 0. So instead of having a dictionary, we're going to have a frequent variable, which is equal to one of these numbers. And we're going to have f times, which is equal to the number of currents of the number that we're iterating through. And essentially, if the count of the current number we're counting for is greater than the last number's number of frequents, like it's the number of times it was counted, then we're going to replace frequent with the new number we're iterating through. And we're going to replace f times with the current count, if that makes sense. So essentially, we're going to start with count equals 0. And then we're iterating through every unique number. And then we need to count through input. So we need to iterate through input. For I in inp, if I equals u, count plus equals 1, count equals count plus 1. So this is how you increase count by 1 every time we find the occurrence in the input list for the current unique number that we're iterating for. And now at the end of this for loop, we're going to see if count is greater than f times if count is greater than or equal to f times, then frequent equals our current unique number, and then f times equals count. And now this pretty much means that it'll update the unique number that is the most frequent and the number of times that it appears, if the number of times it appears is more frequent than the last one that was most frequent. And yeah, essentially, I think that should work. If we print frequent now, yeah, this should work now. All right, 2. So I mean, that works for the sample input. Put for that. I'm gonna use sample input 2. F5. Output's 3. that is what the sample input says, or the sample output. This should have a sample output of 5, clearly because 5 appears the most here. And yeah, if we run this, should say 5. Yep. So it's 5. So this is the solution to practice problem 3, or practice problem 2. What it was is that we looped through the unique numbers, and for every unique number, we just check if it was the most frequent unique number by iterating through the input list. And that is all we have for Python Learnathon. Let's see, you guys have any questions? It's a nice teaching you guys Python. Other than that, there is a bonus problem coming up after this. You can get for points. Sorry, you can solve 4 points. It's a little, not really mathematical type thing. It's more of a fun user interface. Yeah, that's pretty much what it is. Other than that, you guys are free to go. No problem.